Hello and welcome to a video on statistics and data. My name is Mr. Bell and let's get started. Question number 1 gives us a list of data and it asks for 3 vocabulary words. It asks us to find the mean, the median, and identify an outlier. Well, let's talk about the mean first. The mean is simply when you add up all of the values of your data set and then you divide that total by the number in your data set. So for example, in this case, I would need to add 10 plus 15 plus 12, 17, 15, 11, and 30. And then once I add all of those members of my data set, I need to go back and divide by how many there are. In this case, there are 7 members of the data set, to give me a mean or an average of approximately 15.7. Next vocab word says median, and median represents the value exactly in the middle of the data set, except you have to remember one thing. You have to remember to rearrange your data set in ascending order, which means from smallest to largest. So what I'll do now is I'll rearrange my data set. Looks like the smallest number is 10. We have an 11, a 12, a couple of 15s. We have a 17, and we have a 30. So there's my data set rearranged from smallest to largest. And what you can kind of do is either circle or cross out the ends all the way down until you land on that number exactly in the middle of your data set. In our case, the median of this data is 15. And an outlier, by definition, an outlier is a member of the data set that doesn't necessarily belong. And in most of the cases in this class, it'll be quite obvious to see which one does not belong. So if you're looking at these numbers 10, 11, 12, 15, 15, 17, and then 30, you might realize that this number 30 is far above the rest. So the outlier in this case that probably doesn't belong or probably was a statistical mistake or an anomaly is the value 30. Question number 2 also gives us a set of data, and we have 3 more vocabulary words to deal with. We have mode, range, and outlier again. Well, mode is looking for the value that occurs the most. It occurs more frequently than the other values. In this case, when we look at our data set, we have 2 100s, but only 1 of every other value. So our mode in this case is 100. The range is acquired by taking the largest value, in our case it's 100, and then we're going to subtract the smallest value, which in our case is 40. So the range of this data set, the spread, so to speak, of this data set goes from 40 all the way up to 100, which is a range of 60. Outlier, again, is just the value that doesn't necessarily belong with the others. I think if we looked at all 6 of these values, 90, 95, 40, 80, 100, and 100, we might notice that the 40 is much, much lower than the other members of the data set. Therefore, 40 is our outlier. Question number 3 is a set of data points. We're asked to find the mean. And remember, mean is the same thing as average. So we're going to add our data set, each member. So 38 plus 40 plus 50 plus 35 plus 42 plus 40 plus 75. Once we get that sum or that total, we're going to divide all that by how many values there are. There happen to be 7 values in this case, in which case when I divide that, I get a value of 45.7, which is the mean of this data set. Median is the value that occurs exactly in the middle. However, you've got to remember to rearrange the data set. So my smallest number here is a 35. Continuing on, there's a 38. There's a couple of 40s. There is a 42, a 50, and a 75. So what I'm going to do is start from the ends, and in this case I'm going to circle my way to the center of the data, or the exact middle, and it looks like in our case the median is 40, and an outlier is just looking for the value that doesn't necessarily belong with the rest. In our case, I believe that 75 is a much higher value than the other. So the outlier in this case is 75. Question number 4 includes a set of data. We're asked to find the mode. And recall the mode is the one that occurs the most. So if I look at all these values, I see I have 3 60s and only 1 of every other value. So 60 is definitely our mode. The range will be the largest number minus the smallest number. That would be our range of the data. In our case, it looks like 70 is the largest value and a 20 is our smallest value. So from 20 all the way to 70 gives me a spread, or a range of 50. And the outlier is the value that looks like it doesn't belong with the rest. 20 looks significantly lower than the others, so it represents our outlier. Question number 5 says, draw and label a box and whisker plot for the data set. So let's talk about a box and whisker plot, how to do it, and why we do it. So one of the first things you need to do is rearrange your data set in ascending order, which means from smallest to largest. So I'll do that first. We have a 10, 11, a 12, a couple of 15s, have a 17 and a 30. The next step for our box and whisker plot is we'll identify the lowest value of the set, or the minimum value. In our case, it's going to be 10. We'll go ahead and identify our maximum or largest value of our data set, which happens to be a 30. And then to build the box part of our box and whisker. So we need to identify the median as our first step. And remember, we do that by working our way towards the middle of the data set. In our case, our median value exactly in the middle here is a 15. Okay, and the way we find the other ends, the left end and the right end of our box, is by finding the median of the top half of the data and the median of the bottom half of the data. So let's start with the lower end. We have 3 numbers here at the lower half. The median of that part is 11. And then the median of the top half of the data set happens to be a 17. And then we'll just connect those 3 values, so to speak, there in the middle to represent our interquartile range. We'll connect our box and whiskers together. And now we've created something in mathematics called a box and whisker plot of our data. So let's talk about sort of why it's important. Sometimes it's efficient or effective or necessary to group data in groups, for lack of a better word. In this case, our box and whisker is divided into quartiles or quarters. So this left whisker represents 25% of the data set. The left side of this box also represents 25% of the data. The right side of the box represents 25% of the data, and the right whisker represents 25% of the data. Therefore, we can very quickly look at this and tell where half of the data landed. We can easily see that 50% of the data scored 50 or higher. Between 50 and 30 is where the top half, well, the lower half of this data scored between a 10 and a 15. We can see that information very, very quickly. So let's label this. Sometimes different textbooks and different questions will label the quartiles or the quarters. And the left side of this box here is often labeled as quartile 1. The median in the very, very middle that we did on that very first, at the beginning of our box, is labeled quartile 2. The 17, the median of the top half, represents quartile 3. And Sometimes they'll label the 30, the maximum value, as Q4, as quartile 4. But basically what we've got here is we've got 4 different quarters of data represented by a box and whisker plot. Question number 6 says to draw and label a box and whisker plot for the data set. We talked about that on the last slide, so let's get started. One of the first steps you need to do is rearrange your data from smallest to largest. So our smallest value here is a 35. Looks like we have a 38, a couple of 40s. We have a 42, a 50, and a 75. Let's go ahead and identify the minimum value, which is a 35. That's easy. A maximum value, which is a 75. Let's go ahead and try to find the middle of our data set, the median. In this case, the median value is 40. We need to find the median of the top half of the data now. Well, that's going to be our 50. We need to also find the median of the lower half. In our case, it's 38. And now we can complete our box and whiskers. Our 38 here, the left side of the box, represents our quartile 1. The exact median of the entire data set, the 40 here, represents quartile 2. And the 50, the median of the top half, represents quartile 3. And remember that each of these sections of the box and the whiskers represents quartiles of data, or the quarters of data. So 25% lands here, 25% lands here, 25%, and 25%. There is your box and whisker plot to quickly recognize the range, the maximum minimum values, how many and what values represent the lowest 25% of the data, and what values represent the highest 25% of the data. It's quite useful when you're dealing with statistics and data. Just for learning reasons, sometimes you're going to be asked for what is the value of the interquartile range. Interquartile range is achieved by taking Q3 and subtracting Q1. In our case, 50 minus 38 gives us a value of 12. So this data set has an interquartile range of 12. Question number 7 gives us a table of values and a X and a Y axis that are labeled 9th and 10th graders and then boys or girls. And the question says how many students are in grade 10 and what percent of 9th graders are girls. So sometimes this is called a two-way table or a two-way frequency table, and you just have to really look at the data that's provided to you and what question's being asked. In this case, how many students are in grade 10? I would need to look here at the grade 10 category, and it's asking me for the total number of students in 10th grade. I would get that from doing 70 plus 50, and that gives me 120 total students, boys and girls, that are included in the 10th grade. The second part of this question says what percent of 9th graders are girls? So we're only looking at 9th graders, and very specifically we're looking at the percent of 9th graders that are girls. So when you take percent, remember percent is part divided by the whole. In this case, the part we're looking at is 60 divided by the whole, meaning how many total students are there in the 9th grade. Well, that I would get that from doing 60 plus 75. When I figured out 60 divided by the total number of 9th grade students, 60 plus 75, I get a percent of approximately 44. So approximately 44% of 9th graders are girls. Question number 8 is another table of values. This time we have boys and girls along the x-axis, and then our y-axis has pink and blue. Question number 1 says what percent of boys picked blue? And recall that percent is part over the whole, is the part over the whole. In this case, the part we're looking for, the percent of boys that pick blue. So we're looking for boys that pick blue. Okay, so we have 90 that pick blue. And the whole, how many total boys are there? Well, you get that value from doing 90 plus 10, which is 100. So 90 out of 100 gives us a value of 90%. So in this case, 90% of the boys that voted picked blue. Question number 2 says, how many people chose pink in total? So I'm looking for all of the particular votes, both boys and girls, that selected pink as their answer. In our case, we can do 10 plus the 70 to get our total number of people that chose pink, and that would be 80. Question number 9 has a two-way table with men and women on the x-axis and beach and mountain on the y-axis, and some of the parts of the table are not filled in. We also have some totals around the outside of our box. And question number 1 says complete the two-way table. So we're going to use these numbers that were given to us and find the values that go in the missing boxes. So looking in this direction, we have our total there on the outside, which is 100. But our table only tells us that 60 women selected beach as their choice. So we can do 100 minus that 60 to figure out the value of men that voted for beach. It has to be 40, because 40 plus 60 gives me that total number of votes there being 100. Down here for this other missing box, so we know that 120 total people voted for mountain. 100 of them were men. Well, that leaves us a value of 20 women must have also voted for mountain. And now we can find the totals for our vertical columns. 40 plus 100 there gives us 140. So there must have been 140 men in total that voted. And then our 60 plus 20 gives us a total of 80 women that must have voted. And so we've completed our table. So we took care of part 1. Part 2 says how many more men participated in the survey than women? Well, our total men in the survey was 140. And it wants to know how many more men than women voted, and there were 80 women that voted. So the answer to this question is 60. 60 more men than women voted in this survey. Question number 10 says find the standard deviation of the data set below. Standard deviation is just a formula or a calculation in statistics that talks about the spread of data and how spread apart they are. One great tool that we can use for this is the Desmos graphing calculator, and we can go to the statistics feature on it and actually calculate the standard deviation. So I'm fixing to change screens to that calculator. Now that we've pulled up the Desmos.com graphing calculator, what we can do, we've graphed on this before, but now we're going to go down here to the bottom right where it says functions, and it brings up some options. Lots of different things we can use, but we're going to stats to represent statistics. And specifically, we are looking this time for the standard deviation. So I see it on the far right column, the third one down. And now I've got a situation in the top left of my screen where I've got to put in my data values. They were 80, and then it wants us to use a comma to continue putting in data points. So we have a 70, 60, there was another 70, an 85, a 100, and a 90. And simply by using this statistics feature on this graphing calculator, You can look at the top and see that our standard deviation was calculated for us to be 13.67 if we rounded to the 100th spot. Question number 11 says, use a calculator to determine the equation of the line of best fit. Okay, we remember that the equation of a line is y equals mx plus b. We learned that a while back. And in this case, we've got a set of data, we got a table of data, and it's not a perfect linear function, but it's going to be relatively close. And what we're going to do is we're going to use a calculator to discover the trend line, or the closest line that approximately represents this data set. That's why they call it a line of best fit. It's not the exact perfect line, as most data in the real world is not perfectly linear in nature. So in this case, I'm going to show you how to go to the calculator, input this data, find the line of best fit, and we're also going to talk about something called the correlation coefficient once we get to that calculator, and we'll talk about its meaning here in just a minute. So here we are back to the Desmos.com graphing calculator. This time we're going to do a new feature on this calculator, and we're going to hit this top left of your screen. There's a plus button, and it opened up some options, and we're going to click table. And now we're going to input all of those values from the question before. So we had an x value of 4, 7, 9, 12. We also had a 15 and a 20. And now I'm going to go over to the y column here and input the y values of those data points. And there was a 10, a 8, a 6, a 5, a 3, and a 0. So now that I have my data plugged in to the calculator, you can see at the top right of the graph, those points have been plotted for you. You just may have to adjust your screen a little bit to be able to view those points. Now let me show you how to find the equation of the line that goes through those data points as close as possible, known as the line of best fit. So we'll go to our second line here, and this just takes some practice. So we're going to do y equals mx plus b, but we're going to be specific to the first entry into this calculator. So I'm going to pick y and the number 1. Okay. I also need to select this ABC in the bottom left of your screen to bring up some options, and since our equation isn't perfect, we're going to pick this sort of squiggly symbol that represents approximately. Okay, we're also going to pick M for our slope, X, but we're going to be very specific about the X values we want also from the first data set that we entered. So I need to go back to my numbers and pick 1. And it's y equals, or approximately equals, mx plus b. So we have to do plus our b. What you may notice now is the line that the calculator provided you, the line of best fit, is in green, it looks like. And it goes through the middle of the data as close as possible. So even though it's not an exact science, if we were to pick points on this trend line, it follows the pattern of the data pretty closely. We can see that it's decreasing as x goes from left to right. And we know our y-intercept over there is a little bit above the number 12. So we got a lot of good information. We have our line of best fit that we could calculate and fill in the information. If you look over here on the second line under where we typed in the y1, approximately mx1 plus b, at the bottom there it gives you your m and b to plug into your question. The m is negative 0.6, representing the negative slope, and the b value was 12.18, which also represents our y-intercept. We could plug that into our box, our line of best fit would be y equals negative 0.6 plus 12, or plus 12.18 if we wanted to. Let's talk about another value there. It's the letter r. R in this case is equal to negative 0.9955. R is what's known as the correlation coefficient. Now I'm going to go back to our other slide so that I can draw some information about correlation coefficient. Now we're back to number 11, and I filled in the M and the B from our graphing calculator, and it represents our line of best fit. Let's talk about the correlation coefficient. The correlation coefficient sort of works like this. Think of it as going from -1 all the way to +1, and there's an infinite number of numbers in between those two. Well, if your correlation coefficient, the closer it is to a -1, it means it's a very strong negative correlation. Remember how our graph of this table was going down? It was decreasing, hence a negative correlation. And since negative 0.9955 is very, very close to -1, that means it's almost a perfect line that's going negative. It's those points, the data set were very, very close to the trend line. They were not spread out very far. Okay, as your values get closer to 0, exactly in the middle, it represents a weak correlation. And if it's slightly to the left of 0, it would be a weak negative relationship. If it's slightly to the right of 0, it would be a weak positive relationship. Well, as our values get closer and closer to +1, this would represent a strong positive correlation. And that would be if our line was going positive, increasing from left to right, and the data set were compacted very tightly to that line, would represent a strong positive relationship. That is your definition of correlation coefficient. Question number 12 again says to use a calculator to determine the equation of the line of best fit. We talked about that on the last slide. So what we'll do now is we'll transfer this data to our Desmos calculator to acquire the equation of the line of best fit, and then we'll discover the correlation coefficient, and we'll come back and talk about it. All right, going through the steps again, I need to click the plus sign on the top left over here. We're dealing with a table this time of values. I'm going to input my x values first, in which case I have a 2, a 4, a 6, a 8, a 10, and a 12. Now I'm going to go to my y column, type in my y values, making sure they align properly with the correct x value. So there's a 3, a 6, a 10, a 12, a 16, and a 20. So now I have my data set plotted. We can see a couple of them on there, but we may have to adjust our graph to see them all. It definitely appears to be increasing this time. The trend line is as x increases, y is also increasing. But I want to find that exact line of best fit, so let's go through those steps again. Remember, I'm going to do y equals mx plus b, except not equals. I'm going to click my A, B, and C and click the approximate button. And now I'm going to select M. Ooh, I forgot something. Our y value has to be specific to the first entry up here. So I have to put y1 so that it knows to pull those data points that I put. So I'm glad that we made that mistake so that it's a teaching moment. And then we'll do our slope and then our x values, which also need to be numbered from which line of this calculator I pulled those x values from. And then it's going to be plus the y-intercept, which is b. And now I have my trend line, and you may look over here at the green line. It's pretty accurate. It goes through the data very, very well. I can see that my y-intercept is below 0. It's slightly negative, and our graph is increasing. So looking here at the values it gives us an m, or a slope, of 1.67, and a b value, or a y-intercept, of negative 0.5, and it gives us an r, a correlation coefficient, of 0.9968. So we'll go back to our other screen and input these values and talk about them for a second. So now I have plugged in those values that we discovered from the calculator for our equation of the line of best fit, and it's y equals 1.7x plus y-intercept of negative 0.5. And remember, our correlation coefficient in this case is 0.9968, which is very close to 1, but not perfectly on the 1. That means our correlation coefficient represents, in this case, a very strong positive correlation, because the data set points were very close to that trend line. It was tightly packed. This was a good line and a set of data that follows the trend very, very closely. Question 13 again says to use a calculator to determine the equation of the line of best fit. So without further ado, we'll go to our Desmos graphing calculator, input our data, and get our equation and correlation coefficient. Now we'll input our data points. Remember to hit the plus sign on the left side of the calculator here to bring up some options. We need our table. We'll input our x values. In this case, we have a 10, a 20, a 30, a 40, a 50, and a 60. So we'll go to our y values now. And our y values were 100, 70, 90, 50, 20, and 0. You may notice that these values are quite large values, so we would need to zoom in our graph probably a fair amount to catch these data points. There they are. I had to zoom in, and the scale of this graph changed quite a bit. Now we're in units of looks like going by 20s. We can see that the general trend is negative. It's going down, but let's see if we can find the exact equation of the line of best fit. Remember, we're going to select y, and we need our first input values that we put here for y1. Click ABC, click the approximate button, since our line of best fit is just the best one we can come up with. We need our slope, our x values from the first input set, but we also need our plus b to line it up as good as possible. What you may notice now is we have a slope of negative 1.97 and a b value of 124. It kind of makes sense that the y-intercept was very, very high on the y-axis. And then this correlation coefficient is 0.9368. So let's go back to our other screen and talk about the information. Back to number 13. Now we've put in place of the slope the negative 1.97 that we discovered. And then our 124 represents our b, or our y-intercept. Now we have our equation of the line of best fit. We have a correlation coefficient, which was r, and it was negative 0.9368. So what you may notice is this number is still relatively close to -1. So it is still considered a strong negative correlation. But notice how at 0.93 instead of negative 0.99, that it's not as strong as our previous examples. So negative 0.93 is a little bit closer to 0 than negative 0.99 was. I do still believe these are both fairly strong negative correlation coefficients, which means our pattern does land relatively close to that line, but this set was not as tightly packed. as our previous examples. Looks like we have one more example of these. Number 14 says to use a calculator to determine the equation of the line of best fit. We're going to take our data, plug it into the calculator again, get the equation, look at our correlation coefficient, and then we'll come back to this screen to talk about it. All right, let's input that data. We're going to hit our plus sign over here to select the table. We're going to input our table values, which were 4, 5, 6, 7, 8, and 9. And let's go input our y values now, which went from 50 to 40 to 30 to 20, 10, and 0. Now we have our data set plotted. I'm going to zoom in a little bit so I can see all my data. There they are. It's definitely going down from left to right, and it's a very steep slope. Let's go to our second line here and actually come up with the equation of the line of best fit. Remember, we're going to hit Y, ABC, and the approximate button. But again, I forgot to put the 1 so that we are sure to get our actual data set. And now we need our slope, which is M, our X values from that first set that we used. And then we have to do our plus B. And here's our equation. We have a nice slope of -10, which represents down 10 and to the right 1. We have our B, which represents our y-intercept of 90, which I would have to zoom in a good bit more to get that value on the screen. And you may notice that our correlation coefficient is a -1, which is as strong of a negative correlation as possible. So let's transfer this data back to our other screen. Now we're back to question 14. I've plugged in my -10 in place of the M, which is the slope of my line or the rate of change of this set of data. And then my 90 was my y-intercept. So now I have my equation of the line of best fit. And remember that our correlation coefficient this time was -1, which is a very, very strong negative correlation because the points were not just close to the line, they were actually on the trend line itself. Question number 15, we have a coordinate plane with some points on it. And number 1 says to draw a trend line that fits the data. So this time it just wants you to sort of draw one by hand. What I want you to see is one example of not a good drawing and one example that is pretty good. So let's start with an example of a trend line that's not so good. Okay, so that line that I just drew does not represent the data very well. It misses most of the points. So let's try again and see if I can do one a little better. So I need to go somewhat between all the data sets. That's not a perfect drawing just by doing it by hand, but this blue line represents a pretty good line of best fit that's got a few points above the line, a few points below the line, but pretty close. What type of correlation is the data? Well, this is certainly a positive correlation because it is going from left to right, and it's increasing from left to right. And I would say this is a relatively strong positive correlation because the data points, they're not spread out all over the graph. They're fairly close to that line. So it's the same information on the previous problems that we did on the Desmos calculator, except this one just wanted you to observe it and do it by hand. Question number 16 says the following scenario has a correlation. Does it also demonstrate causation? Explain. So we have a couple of vocab words here. We have correlation and we have causation that we need to talk about real quick. Correlation just means there is a trend in the data. Okay, so these two values have some sort of trend. Maybe they both increase, maybe they both decrease. Either way, there is a correlation in their data. Now the word causation means, did one of them directly cause the other to change in the way that it did? Or is it just sort of a coincidence? You have to be real careful when you're analyzing statistics and you're watching the news and they tell you something, they give you a scenario where, oh, well, because this is happening, that means this is going to happen because the data says they're both increasing at the same time. Well, sometimes it's just a coincidence when that happens. There is a correlation, but not necessarily causation. So in this case, the question is asking about temperature outside and ice cream sales. So I'm assuming that when the temperature outside goes up, it gets hotter, that the ice cream sales probably goes up too because people are buying more ice cream. As the temperature goes down, it's possible that less people are buying ice cream because it's cold outside. So this is an example of a correlation. There is a relationship between the data of each one, but just because the temperature goes up outside, it doesn't mean that every single person is going to rush and go buy ice cream. It does happen frequently, and there is a relationship there, but in this case, there is not causation. So in this case, there is no causation. It doesn't directly affect one another. Just because the temperature goes down, that does not necessarily mean that Mr. Bell's not going to go buy ice cream from the store. I'm going to eat ice cream if it's cold or if it's hot outside because I like the way it tastes. So this is an example of two things that have a relationship, have a correlation, but not a causation. Question number 17 says to find the value of X. So we've got a data set and we have a missing value that we need to find. So we have 2, 8, 9, 7, 6, and then the missing value. And it says a very important piece of information that the mean is 6. So we're going to use algebra here to solve for that missing value. So if I'm thinking about the mean, I remember that the mean is when I take all my values, I add them together, divide that set of data by how many values there are. In this case, there are 6 total values. That will give me the mean of the data, which in our case is a 6. So what I'm going to do now is I'm going to combine some like terms and simplify and solve this equation for my missing value. So on top, 2 plus 8 plus 9 plus 7 plus 6 is 32 plus X divided by 6 is equal to 6. I'm going to cancel this divided by 6 on the left side by multiplying both sides by 6, giving me 32 plus X is equal to 6 times 6 is 36. And then I'll subtract this 32 from both sides in order to solve for X. My missing value is 36 minus 32, which is 4. Question number 18 says find the value of X, and it's similar to last time. We have a set of data here, and we have a missing value that we don't know what it is. We're going to solve for that. We know what the mean is. The mean is 14, so let's get started. So remember that the mean is accomplished by adding all of the value. So we'll do X plus 9 plus 10 plus 12 plus 20 plus 25. We'll need to divide all those values by how many there are. There are 6 total values. And we know that if we added them all up and divided by 6, it would give us a mean of 14. And now I'm going to use algebra to solve for my missing value. So in this case, 9 plus 10 plus 12 plus 20 plus 25, I believe is 76. Divided by 6 is equal to 14. We need to get rid of that divided by 6 by multiplying both sides by 6. In which case I'm left with X plus 76 is equal to 14 times 6, which I believe is 84. We'll need to subtract this 76 from both sides to get our final X value of 84 minus 76, which is 8. So the missing member of my data set is 8. Question number 19 is very similar to the other example. It's just worded differently. This says, what is the minimum grade on the last test needed for an average of 90? And then we have our test grades here, 80 and 90, 195, 85, and our missing value. So let's get started. So we know we need to add up all of our grades, x plus 80 plus 90 plus 100 plus 95 plus 85. We'll have to divide all those test grades by the number of them that there are, which is 6. And that's going to equal my average for the class, which in this case, I want to have an average of a 90. So now I'm going to use algebra just like I did before. 80 plus 90 plus 100 plus 95 plus 85 is 450. All divided by 6 is equal to 90. We have to get rid of that divided by 6. We'll do that by multiplying both sides by 6, leaving me with x plus 450 is equal to 90 times 6, which is 540. We'll subtract that 450 from both sides, leaving me with a final test grade that I need of 540 minus 450, which is a 90. So I need to make a 90 on that last test to have an average of a 90 for the course. Question number 20 is similar to the last one. It says, what is the minimum grade on the last test needed for an average of 65? This time we're just trying to pass the class. So let's look at our data. So we have our missing test, our last one, plus 100 plus a 0. Hopefully we were just absent for that test and didn't actually make a 0, plus 270s plus 60. We know that I'll have to divide that total by the number of test grades that there are, which is 6 in total. That'll give me the average of 65. So let's do some algebra here. 100 plus 0 plus 70 plus 70 plus 60 is 300. Divided by 6 will give me 65. I need to cancel that divided by 6 by multiplying both sides by 6, giving me x plus 300 is equal to 65 times 6, which is 390. We'll subtract that 300 from both sides. Just to get a passing average of 65, I need to make a 390 minus 300. I need to make a 90 on my very last test. So I had better study hard to make an A on that last test. All right, thanks for watching. I hope this helps.